Okay, everybody, this is Dr. Welker, lecture module 5b. Here we're going to work on the profitability index. Very straightforward. Idea is this, right? We're going to have a decision rule. If the profitability index is greater than 1, we're going to say yes to the project. Okay. If the profitability index is less than 1, then we say no. This jargon, profitability index, is what's common in corporate finance. Over in public finance, the government jargon is that it's called benefit cost analysis. Either way, it's calculated the same way. Okay? The profitability index is going to be a score that you'll generate. Let's have a bracket right here. And take the sum of cash flows. They're going to be discounted cash flows. So take flows through time, where time is equal to time period 1 through t. Discount those flows at 1 plus r raised to the t. And then divide by the time period 0 cash flows. Now it's the negative of the cash flow at time period t equal to 0, right? So you should know what this equation is basically telling us, right? It's saying, well, if the profitability index is greater than 1, then the present value of the inflows is greater than the present value of the outflows, right? So net present value is positive, right, when the profitability index exceeds 1.0. So you're going to get, think of it as basically the same result. The decision rules here converge, okay? If you looked at an individual project and you're making your decision using the profitability index method, you'll get the same decision as when you use the net present value method. See, so one of these methods says accept, and the other method also will say accept, okay? When one of them rejects, the other will also reject. But the profitability index can give you accept-reject signals that will conflict with the net present value rule when you have to rank projects against each other. So that's kind of a little problem, a little critique, right? You get mixed signals, right, with the profitability index. When you are ranking, right, possible projects. So you're looking at, hey, what am I going to invest in, right? So this implies a question, right? When is it the case that you must rank, right? When must you rank projects? See, so the projects are ranked in usually one or two kind of conditions that are going on. The first is that the projects are mutually exclusive. You know, they kind of sit on their own on the corporation portfolio, not having impacts on one another, right? Or, right, it's either one or two of these cases, or what's going on is the firm, right, is capital rationed, right? It's practicing capital rationing because it has a budget constraint. Now, by mutually exclusive, we're saying you can take one project or another project, and you cannot take both. So you might have a corner lot where you can put up a game store or a gas station, a parking lot or a flower shop, and you can't do all things in that lot, right? You have to pick one project. So your options are mutually exclusive in such a case. By capital rationing, we mean that the firm has a lot of good projects. It has, let's say, some capital that will fund these projects. And most of us actually on a personal level will do capital rationing most of the time. Now, what will happen in the context of the corporation is it will seek out capital markets, right, to obtain money, but there might be a capital market imperfection of some sort that's causing a rationing system to have to operate for the firm, okay? So what's going on here? We want to do a basic example to see, let's see, we're going to do mutually exclusive projects. And these mutually exclusive projects are A and B, okay? So project A and B. Let's do some analysis. Let's say you've got cash flow, right? Time period 0. Firm A is minus 1,000, and firm B minus 10,000. Okay, much bigger project, right? Let's say cash flow in time period 1 looks like 1,500, and let's say 13,000 for project B. Let's see about our net present value, right? And again, we'll do a 10% discount rate. Okay, so the net present value of project A is 364. Of project B, it's 1,818. Okay, so both projects look viable. They're both positive NPV. Now look at the profitability index score that you get. Right, project A gives you a profitability index of 1.36, project B of 1.18. Both are good projects. If we could do it, we would take both. The example is illustrating that if you had to take them one or the other, of course, they're both good projects, it looks like. And you note, right, the projects being mutually exclusive, and therefore we can only take one, notice that the NPV rule tells us to take project B, right? So the NPV rule says, hey, project B adds, right, it's adding more wealth, right? And it turns out that if you decided, hey, let's use the profitability index rule, let's use that rule, now it's telling us that, right, now you're going to take project A. It has a higher profitability index. Okay, so now we have a conflict. The two procedures are telling us different things. Now remember, our goal is to maximize shareholder wealth, and our shareholders don't spend an index score. They spend money. They need cash. So we would choose project B. Given that we can reference shareholder wealth, right? That's what's kind of a key criteria for us. Notice that the profitability index, right, it did not properly consider the scale of the project. So this larger index score, see, notice what it did. It said, look, you have invested some capital, and you're getting kind of a big bang for your buck, you might call it. And thus, right, the smaller project will tend to have more profit per dollar, right, invested. And those large projects that actually wind up increasing shareholder wealth by much larger amounts, well, they'll tend to have much lower PI values. Right? Let's do another example. Let's do one under capital rationing. Say you're capital rationing. Now, here's a point where we'll mention, right, that the B and D book. See, this is all chapter 6 in B, Berkman and DiMarzo. Burke and DiMarzo, I think, make a mistake. They say, look, when there's capital rationing, use the profitability index so that you can rank your projects. But I think we should disagree with that. Let's say your firm has a capital budget of $25 million. Again, it could be something going on in markets that an imperfection has arisen and we can't raise more money at this point in time. Let's say interest rates are running at 15% and we have 6 projects that we're looking at. Okay? Let's say that the 6 projects, we'll say this, all have net present value that's greater than 0. Immediately you should recognize, that all, likewise, they all have profitability indexes, that are greater than 1.0. The projects are, let's say, not mutually exclusive. Let's say this, you'd like to accept all 6 projects, but you really don't have the funds to do so, So you've got to figure out a way to allocate money to something you would rank as first, Something else you could rank as second, and so on. Let's look at our data. Now, let's imagine that this is all in millions, okay? So the data is projects A through F. There's projects A through F. Let's say we have an outlay, cash flow. In outlay terms happened in time period 0. It's 25 million project A, okay? 20 for B, 15 for C, let's say D is 10, and then E and F are going to cost us 5 million, okay? Let's imagine the net present value on these projects. So A is 8.52 million. B is 5.6. You know what? I was looking at my 2 again. So let's say 5.69 million. C, 1.76 million. D is 1.42 million. Well, E, 3.13, and F, 3.56. Also, we say, oh, well, we figured out the profitability index scores on these. Let's say we got 1.34, 1.28, 1.12, 1.14. E is 1.63, and F is 1.71. Now, the sum of the outlays, so that's 20, 40, 50, 60, 70, 80 million, The sum of the net present values is 24.1 million. Now look at the PI rank, profitability index rank. Just looking at, what gives you the highest profitability index, the highest ratio of profit to cost, Benefit to cost. F is ranked first, E second. See, third is A. Then we got B is actually fourth, D is ranked fifth, and C is sixth. If you have capital rationing, it's going to be a different decision then when you don't have to worry about rationing. Like basically, you would accept all these projects and spend 80 million to generate new wealth of 24.1 million, but you have a budget constraint, of 25 million. See, so suppose that you were going to utilize the method of, the PI method. Under the PI method, you would take projects F, E, and D, So F and E and D, they would generate costs. Well, you'd have to have a total outlay of 20 million. See, these are the highest ranked projects that are still sitting inside your budget constraint of 25 million. See, so you put in F and E and you say, oh, well, see, with F costing me 5 and E costing me another 5, there's 10 out of my 25 million. I've got 15 left, 15 million left. But I would like to take project A. See, it was ranked 3rd. But I only have $15 million left. So I cannot afford A. It cost me 25 million. I can't take B either. See, the analysis assumes that you cannot take 3/5 of project A. You can't take 3/4 of project B. Now, if you could take fractional elements of these projects, the PI ranking system is valid. Okay. Now look, what is the combined NPV of those three projects? So you look at these 3 projects and add up the sum of their net present value, right? Their net present value in combination, see that, 3.56, 3.13, and 1.42, right? So that adds up to 8.11 million. So did the PI ranking method select for us the best set of projects from the shareholder's perspective? And that's what matters here. And the answer is, well, we're going to look at this. We'll say, well, the shareholder's perspective right, is this set of projects the one that they would like? Right? The answer is no. No, no, no. They don't want that arrangement. Now, suppose that I use the net present value approach. Is that the solution I want? What kind of projects would I then take? Notice that, right, project A has the highest net present value, 8.52 million, and you see that it exhausts the $25 million budget. But this is not really optimal from the shareholder perspective. So you'd have to really look at all possible subsets of the 6 projects. You're trying to use up your 25 million, and right, based upon the 25 million, look at the sum of results of the mixing of these projects. Now I'm going to switch to the next slide. If you want to, you could of course back up. What I'm going to do is say, let's take our 25 million and try to allocate it across projects. So we have to create a whole sequence of iterated project types, right? So what we need to do is look at a project or a subset of projects. And what we'll do is say, well, given the subset that we're interested in, we'll look at its time period, 0 cost, right? And likewise, what we should do is, so once I have the particular set of projects in place, I'll be able to calculate the sum of the net present value of the subset. So we should say subset sum of net present value. This way we can look at how I'm using the $25 million. Right now, from before we saw, I could have obtained just project A. It cost me 25 million, right? And I have 8.52 in net present value. Now I could also afford B alongside E. That's using up 25 million also. And here I get 8.82 million, which is right, a little bit better. So that's indicating, maybe that's the movement in the right direction. And then I say, well, I could put in place projects B and F. Again, I use up the 25 million budget, and now I've got, this actually is 9.52 in net present value. Let's go and look at C and D. I could buy C and D at a cost of 25 million. And you'll see, well, that generates new shareholder wealth at 3.18. We can go back and double check that C, E, and F could be obtained for 25 million. Then add up their net present values. That's 8.45. D, E, and F could also be obtained for 25 million. Oh, no, wait. I'm looking at my note. And I realized I wrote the wrong number there, and you can double check by going back. You're spending $20 million there, and there's nothing else available to use this other $5 million for, right? That gets you 8.1. So let's see, the issue is, where's my net present value maximized? Where is it maximized? Right? Let's see, 952 is the use of $25 million to generate new wealth for stockholders, 9.52 million. See, so that's indicating to us that we should be installing projects B and F. So here the firm is capital rationed. It should find basically all the possible subsets of projects and try to find the different groupings to set up all the possible subsets that exhaust the budget, and then look at the combined net present value to find the maximum that would be generated, right? And what capital rationing costs the shareholders, remember, is foregone wealth. Right? Without capital rationing, the 6 projects would be chosen, and they'd generate a combined NPV of 24.1 million. Now, with the capital rationing, you choose projects B and F, and now you get 9.25 million. So what you could say is there's a loss of wealth occurring from the fact that you have to capital ration. So, right, this is something to note, right? We're dealing with the cost of capital rationing. So you can basically say, okay, find the amount of money that you would have generated if you did not have the rationing. You find that was 24.1 million. And subtract how much money, how much wealth you're generating under the rationing, right? You're getting 9.25 million. So you see that the capital rationing is costing the shareholders, right? It's costing them $14.85 million. A steep loss for being sort of, for whatever reason, forced into the capital rationing kind of mode. Should the firm impose capital rationing on itself? The idea would be preposterous in this situation. If you have the ability, then you should invest in all the projects. Okay? Theoretically, the potential of a capital market to be perfect is, out there. That means that you should try as hard as you can to find all the money to cover your positive net present value projects. And the idea would be, look, if you have a good project, you're going to find investors who are going to be willing to supply you with capital. Now, it turns out in reality, a pretty high percentage of firms will impose some capital rationing on themselves year after year. Why that happens is not well understood. There's a variety of possible reasons. Why would a firm turn down positive net present value projects? It could be that they're not finding qualified employees. Maybe they suffer some shortages in raw materials and therefore cannot really initiate these projects. Another reason that you would impose capital rationing would be that maybe you're trying to force managers to prioritize projects. But this prioritization could be desirable, but you're sacrificing shareholder wealth when you're doing this, right? So not good at all. We're going to come to point C next, the internal rate of return methodology. And for now, I'm going to put this up on the internet.